Okay, good afternoon, everyone. Thank you so much for coming to this afternoon's Walras-Bowley Lecture. My name is Parag Pathak. I'm the program chair of this summer's conference, and I'm thrilled to announce our speaker, Botond Kőszegi. Botond is a professor at the Central European University in Hungary. He is a distinguished economist, the winner of the Johansen Award for a top young European economist, who has made significant contributions to theoretical and applied research. And he's made a number of pioneering contributions to the theoretical foundations of behavioral economics and its applications to public finance and contract theory. Let me just say a quick word about the Walras-Bowley Lecture. So this is an annual lecture that the Econometric Society hosts at the North American meetings. Every year, the society, a committee that the society puts together, selects a non-North American member of the Econometric Society to present this lecture. And so I was thrilled that they decided to invite Botond. So let me hand it over to you. Thanks for coming.
Thank you very much, and it's great to be here, and I'm really looking forward to comments on this paper, which is actually quite new. I'm very happy to give it. So it's joined with Paul Heidhues and Philipp Strack. And the starting point of our paper is a hypothesis, I guess, that one can distill from a few lines of research in behavioral economics, which is that people often have stubborn misconceptions about their own motives or inclinations, especially in cases where these can be interpreted as flaws. Let me give you a few examples. So I guess the to economists most familiar phenomenon consistent with this is full or partial naivete about present bias. So there a person underestimates their tendency to underweight the future. This is kind of the best documented, clearest example, and also will be our main application. But then less well documented, less clearly distinguished from alternatives, there are similar notions of mistaken self-conceptions that you can formulate in very different settings. So in implicit racial bias, you could have a racist person who is not aware that they are racist. They think they are non-racist. You could have a person who asks selfishly while thinking that he's being fair. And then we suspect that many aggressive or immoral individuals don't self-identify as such. We haven't really looked for specific evidence, but we strongly suspect that this is the case. Okay, so a common implication of these kinds of misconceptions is that the person may mispredict his own behavior. So for example, a naive present bias smoker may think that he's going to quit soon and then not do it. You could have an employee with implicit racial bias who thinks he's treating all employer who is treating all employees equally, symmetrically, and then end up with a very racially imbalanced team. An aggressive individual could genuinely believe that he will not be violent with his new nice partner, he thinks, but then be just as violent as before very soon after that. So these are all kinds of mispredictions that come from naivete about oneself. So in the paper, we ask what we think is a very natural question, is what does a person who has a stubborn misconception, so misconception that doesn't go away, what does he make of these mispredictions? And we propose that in order to explain to himself his behavior, he's going to adjust his beliefs about other aspects of himself or other aspects of the environment or something like that. So for example, a smoker who smokes more than he wanted to and then he expected to, he will come to believe that unrealistically or exaggeratedly, he will come to believe that smoking is helpful for concentration or socialization or whatever. Okay, so this brings to naivete the perspective of this quickly growing literature on misspecified learning, that people learn, they are responsive to evidence, so they change their beliefs, but they do so with the wrong model of the world. And researchers have looked at a bunch of economically important misspecification, I think, and it's really a nice literature to check out. You know, empirical, very interesting empirical, applied theoretical, pure theoretical questions. But the perspective hasn't been applied to this naivete about one's own flaws, which we think is a central type of misspecification, and leads to theoretically different issues. So we are going to develop a kind of a machinery to think about this and identify some implications. By the way, feel free to ask questions. Don't wait until the end. I've seen that somehow it's not a custom at this conference not to ask questions, but please go for it if you have questions. Okay, so let me give you a few of the insights and then move on to the model. So first, we find that in basic situations, and I'll be more precise about what we mean by this. So in basic situations, naivete is always self-defeating. So in terms of welfare, if the agent thinks that his behavior is less flawed, then it's actually going to become more flawed. So he's going to have more of the flaw. And the smoker example illustrates this. We have a present bias smoker who was already smoking too much. He's present bias, so he's smoking too much to start with. Now, with the belief that it helps him concentrate, he smokes even more. So the change in behavior is in the wrong direction. So this is actually, it's just an example, but it's actually quite a general implication of this mislearning. And then second, we show that in a stable environment, the agent often comes to predict his behavior well. So in this, let's say, first pass test, he is realistic. So in the smoker example, the belief that it helps him concentrate, that allows the smoker to predict that he's going to smoke in 2 weeks if he doesn't expect much to change in 2 weeks. Okay, so I think if you're familiar with this literature on misspecified learning, there's not much of a surprise, but we think it's super relevant because in this particular situation, because it problematizes economists' casual thinking and measurement of sophistication. So always, or almost always, the way economists measure whether a person has a sophisticated understanding of himself is by checking whether they can predict their behavior. By this measure, our smoker would be branded sophisticated, and he is anything but sophisticated. He is undergoing self-defeating belief changes, and he's not optimizing. It's getting worse over time. So we call this type of situation apparent sophistication. And then, despite the person appearing realistic on first pass, there are still some patterns of behavior and beliefs that reveal his naivete. So, just very briefly, he in general mispredicts his responses to a change in the environment. So, for example, when he learns that smoking is more harmful than he thought, he follows empirically realistic addiction-like consumption paths. And then there could also be, across a population of agents, there could be puzzling correlations between beliefs about logically and factually unrelated issues, or between beliefs and tastes. I'll say more about this later. Is there any questions? Okay, so let's see the model. So we are going to take. So I'll show you and concentrate most of the talk on this naive present bias application. We basically want to take a totally standard setting with partially naive present bias and add to it uncertainty about utility and learning. But other than that, it's kind of standard or even simplified relative to other settings. So take an agent who is making decisions over time, and there is a fundamental constant over time, theta, that's relevant for his preferences, utility. And he observes in each period signals or shocks or whatever that are centered at theta. And both this theta and epsilon are normally distributed, which is what we need for convergence arguments. And then in each period, the agent is going to choose an action to maximize for simplicity this quadratic utility, where this is application of present bias. So this first part here is current instantaneous utility of consuming A, where the instantaneous or the marginal utility from this consumption is subject to shocks. So this phi t is a convex combination of the fundamental and this signal. Okay, and the agent is present bias, so he discounts the future by beta, and this consumption generates some future harm. Let's focus on the harmful consumption case, like smoking. And this can be applied to basically any application of present bias, but think of harmful consumption now. So there is there's some future harm that's generated that we discount by the factor beta. Okay, so the this is totally standard, other than this new thing that the agent doesn't know his marginal utility, and that the marginal utility is subject to shock. So what are some interpretations of this? You could think of a situation where the marginal utility depends on permanent and temporary circumstances. So, for example, suppose we are thinking of an agent who has to decide whether to take a payday loan, and whether he wants to take a payday loan depends on his circumstances, his needs. And some of the needs he has already observed. So ST could be expenses that have come up so far this month. And theta could be the average of expenses that usually come up, so what he can expect to come up later in the month. So his needs are summarized by convex combination of the two. Or another interpretation is that a kind of signal extraction situation. Theta could be the average party, I don't know how fun the average party is that I'm invited to. ST is a signal about this weekend's party that I'm invited to. And then I form a phi t would be a posterior, combining kind of the average and my signal is my posterior about how fun I expect this weekend's party to be. Okay, so this is so this is the basic situation, and the agent is time inconsistent. Before entering period t, he prefers to use beta equals 1. So he prefers to maximize kind of the undiscounted difference between the two, and more generally he likes to use higher rather than lower beta. Okay, so now come the key parts. The agent's self-knowledge is limited in 2 ways. So he takes this action in period t, and but later he given these circumstances S, but later he only remembers the action. He doesn't remember the circumstances under which he took the action. It's just, you know, what were the, I remember that I went to the party, but I don't remember the exact information that I had about the party, or the exact circumstances that prompted me to go to the party. That's limited memory. And then in addition to that, the agent is partially naive. So this is again totally standard. He interprets and predicts his behavior based on, he thinks that he had been maximizing and will be maximizing the same utility function, but with the beta tilde rather than beta. And this beta tilde is greater than beta, is the case we'll focus on. So basically, he thinks he's less present bias than he is. And it's also, he wants to be less present bias than he is. So these go in the same direction. He thinks he's closer to what he wants to be. That's the sense in which this is naivete about a flaw. Okay. Any questions? Okay, and then actually a slightly almost the same model, so some slight differences. We could make, instead of limited memory, we could make the assumption that the agent, even at the moment of choice, is not aware of his exact motives. So he doesn't observe ST even at the moment of choice. So an intuitive example of that is that, you know, I could feel an urge to smoke, but not know exactly why I'm feeling this urge. Is it because it's going to help me concentrate, or is it because I'm impatient? I can't really sort it out in my head, or sorry, I can't directly observe it. Why can directly introspect about why I want to smoke. This follows is consistent with the long line of research in psychology that people are not aware of their motives. So that we could make that assumption. But anyway, so these are the agent's limitations. Other than that, he's rational. He has a correct prior about theta and updates his beliefs about it in a Bayesian way. Yeah, yeah. It is a hyperbolic discounting model. So what we add to it is kind of trying to make sense of your own behavior. That's the and so or formally so far is uncertainty about marginal utility and learning about marginal utility. That's the yeah, I'm getting there. Yeah. So I mean, I gave you a flavor of it. That's kind of where we are going, but you'll see in a little more detail. Any other questions? Okay, so so let's just do a little bit of calculations here, so you see that you can do some very simple stuff to try to understand models like this. So just based on the utility function I wrote, just note that this is what the agent is trying to do. He's trying to set AT equal to phi t minus beta kappa, and the phi t is this. Okay, that's just essentially carried over. Now, let's ask the question, when does the agent correctly predict his behavior? So yeah, with what belief? So let's suppose that the agent believes with near certainty that the fundamental is theta tilde. How does he actually behave for a realized error epsilon? So basically, if the error is epsilon, he's going to receive the signal and observe this signal st capital theta plus epsilon. Okay. Now he wants to choose phi t minus beta kappa. He doesn't know phi t, so he's going to form beliefs about it. Let's denote by tildes always beliefs. So he's going to set AT equal to phi t tilde minus beta kappa, and then what's phi t? Well, it combines the st he has observed and his belief about theta, which is theta tilde. So he just does this, and then we know that st is equal to theta plus epsilon. So this is what he's going to choose. So this is what he actually does. Now, how does he expect to behave for a realized error epsilon? Well, for that, look at this expression here for what he does. Now he tries to predict this. So this beta is going to become a beta tilde, and the st is the st tilde. And we have assumed that this, you know, he believes this theta tilde with near certainty. He doesn't expect this to change, so that's theta tilde. So the st tilde he thinks is going to be theta tilde plus epsilon, and then he plugs in. Okay, with this and this. Okay, so now let's try to set these things equal to each other. Let's set the right-hand sides equal to each other. So let's just make this clearer. So we are trying to make these two equal. So let's take out the common parts. And then we have that, fortunately, epsilon drops out. So AT is going to be equal to AT tilde for all epsilon. So the agent perfectly predicts his behavior. if theta tilde is equal to this. So we're writing the equality between these two. Okay, so in this, if this is equal to theta tilde, this is what theta tilde is, it perfectly predicts his behavior. So we call this situation self-observation equilibrium, because if the agent believes this, he thinks he totally understands what's going on. He perfectly accounts for his behavior. He perfectly predicts his behavior, and therefore he sees no reason to change his beliefs. So in this example, it's actually easy to kind of using elementary calculations. You can show that the agent's beliefs converge to this SOE, self-observation equilibrium. So in order to understand long-run behavior, it's sufficient to understand SOEs. Okay, so that's what will happen with the agent in the long run. Okay, so we have a naive agent who perfectly predicts his behavior. So that's one difference from other models of naivete. Okay, so any questions? Yep. It's inspired by that, so it's the same idea, but this is a different kind of misspecification. So so we just have to define a notion. Yeah, so here it's not the signal structure that's misspecified. The agent is misspecified about his utility, so there isn't a one-to-one map to a situation where the signal structure is misspecified, and that leads to other technical issues that you know I can say a bit more about, but it's not the focus of the talk. Yeah. Okay. So okay. So let's look at this formula again. So we have a harmful product. So if beta tilde is greater than beta, so the agent is partially naive, then he exaggerates his marginal utility. So so this is the self-defeating learning that I mentioned at the beginning. There's kind of a double whammy that the agent experiences or whatever. He's present biased to start with, so his consumption is too high to start with, and then his SOE belief raises his consumption further. So he's going to overconsume even from the perspective of present biased utility. Not just from the perspective before period t, when he wants to set beta equals to 1, but even from the perspective of his impatient self, he overconsumes. So the you know, let's say the party goer that I used as an example, the party goer would go to too many parties, even from the perspective of his short-run party-going self. Okay, so that's the basic idea of this self-defeating naivete. It's theoretically possible that consumption is increasing in the harm, but it's kind of a side note. Okay, so how do we think about these situations in general? So in our general framework, we assume that the agent attempts to maximize the expectation of a function v, that's a function of at, st, and theta, but he believes that he's maximizing v tilde. Okay, until when do I have? Is it until 6:35? Okay, okay. So so this is this quadratic case was a simplification. A bunch of issues arise. Let me skip that. So sometimes the agent cannot perfectly explain or account for his behavior or predict it. Then we kind of have to look for the best explanation and define the SOE that way. And then the other issue that's always thorny in this literature is proving convergence in general cases like that. So this is where the different kind of misspecification is a problem in existing work, because the misspecification is on the signal structure. Once you know what action the agent took, you know how they misunderstood the signal. that's not true in our case, because how they misunderstand the signal also depends on what beliefs they had before. So that leads to a slight difference, but we find conditions under which beliefs converge to an SOE anyway. Okay. So then we define an economically natural general class of situations which we focus on in this paper, which we call equidirectional problems. These are problems in which increases in basically ST, increases in ST and increases in theta move the optimal action in the same direction. So, or equivalently, if a signal is higher, then the agent wants to move all actions in the same direction. This applies in situations where the uncertainty that so what the agent doesn't know pertains to mainly to how much to consume. So, for example, when the question is how harmful is smoking, or how much does smoking help me concentrate, this is uncertainty about how much to consume. If you find out that smoking is harmful, then you want to smoke less in all periods. It applies to the question is how much to consume. What this doesn't cover is when the uncertainty pertains to when to consume. So when should I smoke, or when should I do a task or whatever. Okay, so this is the types of settings we are looking at. The one I showed you was a type of equidirectional problem. Okay, and then we generalize the notion of self-defeating misperceptions. It basically says that you do worse. So this V tilde is the wished for preference the agent has. He believes he is maximizing V tilde, and he also prefers V tilde over V. This is self-defeating if he does worse at maximizing V tilde if he believes V tilde rather than V. Okay, so that's the notion of a self-defeating misperception. And then we show that for any equidirectional problem, any decision-relevant naivete is self-defeating. So a decision-relevant means that they imply naivete, V and V tilde imply different actions. So basically, no matter what the agent's motives are, and what he considers, and no matter what he considers less flawed motives or better motives, if he believes that his behavior is less flawed, then it becomes more flawed. So it's quite a general result. Yep. No, I mean, he is misspecified. So he doesn't, I mean, we can see it from the outside that he's in an SOE, but he thinks he just learned. He learned theta. And he doesn't see a need to. He thinks he knows what he's like. He thinks he's kind of not, let's say, not present biased. He sees his behavior, he tries to interpret it, and then he comes to a situation where he perfectly understands what he's doing, but he's still naive. He's still wrong about it. But he can perfectly explain his behavior, and because of that, that's the point, kind of. Because of that, he has no reason to question his belief. So that's the idea, and that's also the idea of Burke-Nash type situations. It's a little hard for the first time to wrap one's head around it, but that's what's going on. So within what his understanding of the world, it makes perfect sense what's going on. If the SOE is of the type that I showed, where it very perfectly predicts his behavior. So let me just illustrate using the variants of this present bias model. just to give you a sense of the generality of this self-defeating thing, perhaps it's perhaps you see it, but suppose I assume that consumption is beneficial, harmful. Let's assume that it's beneficial for the future. Then a present biased agent consumes too little. So he comes to believe that in order to explain that, he consumes less than he wants or expects. In order to explain that, he comes to believe that it's painful to consume, like exercise. Exercise is painful, and I shouldn't be doing it, or it has some other cause. If he believes that he'll exercise even less, it's self-defeating. He was exercising too little to start with. Suppose consumption is harmful and the uncertainty pertains not to the current marginal utility, but the future marginal harm, then he consumes more than he expects. To explain that, he comes to believe that it's less harmful than he thought, and that makes him consume even more. Again, it's in the wrong direction. Let's take an agent who wants and expects to be more present biased than he is. This is a little harder to think about, but let's take somebody who really wants to enjoy the present, but can't. Then he observes himself and wants and expects to enjoy and consume in the present. He consumes less than he expects. In order to explain that, he comes to believe that there is no point in consumption, it's no fun, so he consumes even less. From his perspective, that's again in the wrong direction. So it always goes in the wrong direction. Okay, so how is this, just to wrap this up so far, how is this different from naivete in previous models? So in previous models, naivete, in previous models of present bias, naivete acts through intertemporal interdependence of actions, so through strategic effects. We roll this out on purpose in this model, so this does not act through strategic effects. And importantly, so in the previous models, the agent may act, naivete may lead the agent to act suboptimally because they mispredict their future behavior. Here, they act suboptimally despite perfectly predicting their future behavior. Okay, so and this is now not due to misprediction of future behavior, but due to misprediction of instantaneous utility. So conceptually, that's the difference. And in terms of welfare, okay, I don't want to push this too much, I guess, but one could argue that this is more robustly harmful than previous implications of naivete, because the strategic effects can go either way. They can be positive or negative, and they can be pretty weak in many settings. Okay. Yeah. Yeah, for the self-defeating, it is. Yeah, so it definitely is. I'll give you an example at the end, but the non-equidirectional problems are more difficult to analyze. So we are working on that. It's for future work. So it can be it can go very strongly the other way. You'll see. Yep. No, the person who making the choices also doesn't know. They observe S, but they don't know theta. They are also being affected by this learning. So, and actually, in the version of the model with unawareness, the person making the decision doesn't even need to know S. It could be some kind of feeling, like the urge to smoke, but not directly observe VS. So either they just forget the circumstances, or not even that. And it's so important, actually, the self-defeating nature is because the fact that the mislearning goes back and affects decisions too. That's why a self-defeating learning happens. Okay, so here are some signs of a misspecified agent. So that they can perfectly predict their behaviors. Looks like they are they could be sophisticated. So perhaps the most important way in which they are wrong is that they mispredict their behavior when the environment changes. So one example of that is that they mispredict their response to a change in kappa. So think of that as a change in incentives to behave in a future-oriented way. Kappa is the future harm from consumption. So so it's easy to see that what's the derivative of the A's, A and the predicted A to kappa? Well, in the short run, when kappa changes, beliefs don't change. So beliefs don't change, the observed S's don't change, so these phi t's and these phi t's don't change. So the agent's actual response to a change in kappa is, beta, and his predicted response is beta tilde. Okay, so he mispredicts how he will respond, and this actually now exactly reveals his naivete. So the ratio of the responses is beta tilde to beta. Interestingly, this is a slightly different model. The prediction can be even worse. So things in this misspecified model can be really subtly sensitive to details. So he's going to make even worse predictions in situations when he's learning not about the current marginal utility of consumption, but some future benefit of consumption that offsets the harm from consumption. So you could think of the benefit of smoking for concentration on work as a benefit that's going to accrue in the future because it's from work. The benefit of that is going to accrue in the future, and it offsets the harm from consumption. So the agent mispredicts his response even more to these kinds of, he's way off on this one, because he both overestimates the importance of these offsetting benefit, and he overestimates how much he responds to that. So it's kind of, he doubly mispredicts it. Okay, so our model would predict that a smoker or somebody on a diet in a stable environment, eventually they would understand how they're going to behave. So, so slightly ahead, they could predict their behavior correctly, but what they would mispredict is what happens when circumstances change. For a smoker, for example, they would mispredict what happens. Oh, now it's really stressful at my work. I really need to smoke while it's stressful. But when this project ends and it's not going to be stressful, that's when I'm going to quit. So they may be correct in predicting that they'll keep smoking because it's stressful, but incorrect in thinking that they'll quit. Previous models of naivete, they say that the person always mispredicts. They always think that from tomorrow on, they will behave better than now. Okay, so that's a response. They mispredict their response to the changing kappa. And then an obvious point is that the agent mispredicts his behavior in a new problem with an independently drawn theta, then the whole thing resets. He should have learned, really, if he was kind of correctly specified, he should have learned that his beta is different from what he thinks, but he learned or mislearned that theta is different from what it is. You place him in a new environment with a different theta, then he's going to be wrong again. With correct specification, arguably, the agent should be able to carry his knowledge to a new environment. So for example, a dieter, they may be able to predict, or our model would say that they predict that, oh, this current diet is not working. But when they think about a new diet, kind of independently drawn theta, they think that that's going to work again. So they perpetually go for new diets. And then there could be interesting correlations between beliefs across a population. So I've shown you that if uncertainty pertains to current marginal utility, then the agent overestimates it. If I argue that if the uncertainty pertains to future harm, then the agent underestimates it. What I haven't argued is that if the agent is updating about both, he's going to have both of these beliefs at the same time. I think you can believe me this. So then these two these two beliefs across a population of agents with different levels of naivete will be correlated with each other. So we would predict that that there is a correlation in the population between beliefs that smoking is beneficial for concentration and everything causes cancer. These are the two sides. They're just examples of these beliefs about benefits and the costs, benefits being high and the costs being low. But these are logically and factually unrelated issues. There shouldn't be a correlation in beliefs about these issues. Okay. Any questions? Yeah. No, he doesn't realize that. So which example you have in mind? The first one, like he mispredicts how well he starts adjusting his beliefs about theta again, and then he will arrive at different. I didn't explain this, but yeah. So he will think. So he thinks. Let's say he learns that smoking is more harmful than he thought. He cuts back consumption. That's as you would expect, but he cuts back by less than he thought, and he may be surprised by that, or he will be surprised by that. But then he concludes that, okay, probably smoking is then more beneficial than I had thought. That's why I'm behaving this way. I mean, I'm explaining it in very rational terms. It doesn't need to happen in such extremely rational terms, but that's what happens. So first, he smokes less, but then he develops beliefs that this is better than he thought. So then it rebounds and he starts smoking more again when he gets used to the idea that that this is more harmful in a sense. Okay. Okay. So let me talk about this apparent sophistication. Okay. So there is this large empirical literature that tries to estimate whether and experimental that tries to estimate whether people are sophisticated in intertemporal choice. Essentially, the question is, are people able to learn their betas? It's the question of this literature. And the universal measure that's used in this literature is how well a person predicts his behavior in a situation. So what I showed you already, it clearly problematizes this, because our agent perfectly predicts his own behavior, but he isn't behaving optimally. So there is no sense in which you can call the person sophisticated. Okay, so we call this apparent sophistication. And more generally, the agent, when you on various measures, they may look sophisticated, they may look as naive as he is, they may look more naive than he is. It's kind of anything can happen, you know, if you look at some of these other predictions. Okay, so so let me try to say a little more about this, because we can not only say that there is a problem with this literature, we can say something about what would an econometrician uncover if they didn't account for misspecification of our time. So and we are going to apply this this to a very nice recent paper by Alcott et al. On the sophistication of payday borrowers, and I'm going to argue to you that our theory better explains their findings than a model of correctly specified learning about data does. Okay, so so let's take this previous model with kappa greater than 0. So with harmful consumption, payday loan is harmful because if you take a loan and consume it, then it will hurt you in the future. But then we add a couple of actions to the model. We ask the agent to predict their mean consumption before period T. And we also ask the agent to make a choice that reveals their time inconsistency or their beliefs about time inconsistency. We ask them to reveal how much, ask him how much he values a marginal decrease in his consumption relative to what he expects to choose. So how much do they value constraining their future consumption? Because this is very analogous to how beliefs about time inconsistency and time inconsistency, etc., are often measured, including in this alcohol at all. Okay, so we call the agent inexperienced at the beginning and experienced when they've reached SOE beliefs. And now it gets extremely confusing because we're going to take an observer who observes this agent, and the agent is misspecified, but the observer doesn't allow for the possibility that the agent is misspecified. So the observer is also misspecified in a different way. So you have to be really careful about who knows what or who is thinking what. But anyway, so let's take an observer who is observing these experienced and inexperienced agents, and they have infinite samples of both, so there's no sampling variation. In reality, everybody has the same beta tilde distribution of theta and kappa, so they're all the same. And the observer knows this kappa, they know the shape of the utilities, and they assume that the agents know their utility functions. That's kind of a universal assumption in many studies like this. So so the observer assumes that the agents know their utility, and then allows for beta tilde, these utilities, to differ across groups, and is agnostic. It is kind of a detail, but they need to be agnostic about the variances of the signals. Okay, and what the observer wants to do is to measure the groups beta and beta tilde. And if they can't explain what's going on, then they reject their model. Otherwise, they kind of infer the beta and beta tilde. Okay, so the observer basically wants to understand how the experience changes individuals' beliefs about their time inconsistency or present bias. Okay. So here is the result. For inexperienced agents, the observer correctly understands what the agents are like. So they correctly understand their present bias and their beliefs about present bias. But for experienced agents, the observer is going to agree with the agent in a sense. So the experienced agent convinces the econometrician of his incorrect self-view. Okay, so the observer is going to think that the experienced agent is sophisticated with the beta equal to beta tilde. Okay, so what's the logic of this? Once you think about it, it's quite simple. So the agent correctly predicts his mean consumption. So the observer is going to conclude that he's sophisticated. That's it. According to the observer's model, the only way the agent can correctly predict his consumption is if he's sophisticated. And then essentially the agent's willingness to pay for a decrease in consumption is how much they believe they're gonna undervalue the cost of consumption in the future. So it's that how much internality or externality of them on themselves they are exerting, and that's exactly how much that a simple function of how time inconsistent they believe they are, and the harm. So they're essentially, this is kind of like a Pigouvian tax. The agent wants to tax himself to decrease consumption exactly by the amount by which he undervalues the harm from consumption. So that's 1 minus beta tilde times kappa, and this is independent of beliefs about theta. So the econometrician correctly measures the agent's belief about his time inconsistency in our simple model. So that's the rough idea. They correctly measure the beliefs, but incorrectly conclude that the agent is sophisticated. Okay, so we then have starkly different predictions for what should happen with correct learning. If it was correctly specified learning about present bias, what should happen is that the agent who is initially naive and actually present biased, their belief should move down to their present bias, right? They should learn that their present bias is actually lower than they thought, so the belief should move down to the truth. Our model predicts that if they are naive at the beginning, they will look sophisticated, but the way that will happen is that their measured present bias moves up. Okay, so this is very different predictions. Both of them predict that in the end, the two will be equal, beliefs will equal the measured present bias, but in different ways. So the ours is not a perfect explanation for what Alcott and I'll find, but it's much closer than the prediction of correct learning. So experienced payday borrowers. So inexperienced payday. Actually, I should have said this at the beginning. So Alcott et al. Find that inexperienced payday borrowers are partially naive, quite naive, and experienced payday borrowers are perfectly sophisticated. But the way this happens is mostly through their measured present bias moving up rather than their beliefs moving down. So it's much closer to our prediction than to the standard prediction. And in addition to that, there are some additional patterns that basically bear our hallmarks of misspecification. Perhaps most importantly, they also document that even experienced payday borrowers overestimate their reaction to an incentive change. That's exactly what our model predicts, that I explained. And and then you could try to patch up kind of a correctly specified learning to try to explain this measured present bias moving up, but it won't be able to explain this this fact. Okay. In addition, we think we explain actually an overall theme in the literature. Our model's prediction that learning can happen or in one environment, but then that doesn't carry over to other environments. That explains it. Overall theme in the literature is that in some specific settings, individuals can learn quickly, but then in almost all new settings where researchers have looked at people, many people are quite naive. So that's exactly what this non-transferability of learning would predict. With correctly specified learning, in contrast, if we observe that people learn quickly in individual settings, then they should very quickly learn their average present bias or whatever. So then they shouldn't be off in new settings either. Okay, so any questions? Oh, that's a tough one. So we thought about that, but we didn't get very far. So one question you can ask is, it's not quite regulatory, but kind of more on welfare. A simple question you can ask, okay, so this econometrician will be off. They won't learn the right thing, but let's say the econometrician uses their estimates to try to make welfare statements. How bad would that be? And we say that on almost anything they predict, they would be too optimistic about the agent. So if I don't want to jump to conclusions about what that implies about policy, that's always difficult in these cases. But yeah, so it definitely matters for conclusions, and that's how. So it's kind of relevant because the way I think many interpret this paper is that people very quickly understand what they're doing, so they should be okay. They should take measures to protect themselves. That's overly optimistic. Yeah. Okay. So let me. What should I do? Let me let me not talk about dynamics, but let me just mention how you can use this kind of framework in a totally different setting, almost without changes. And maybe you are anticipating this, so it's obvious, but let me just point it out anyway. So let's think about implicit bias. So as many of you or most of you know, modern variant of prejudice is when a person consciously endorses egalitarian views, but at the same time, subconsciously or secretly, they hold prejudice. So here is where these are two different hypotheses. When a person endorses egalitarian views, but then you see them somehow reveal that they have prejudice anyway. Is that because they themselves are not aware of it, or they're trying to keep it a secret? It's not obvious. And I tried hard to find papers in the literature that distinguishes these two hypotheses, but I couldn't find any, even though some of them are aware of this difference. We are going to assume for our papers, and it's important, that it's subconscious. So they are prejudiced, but they themselves are not aware of their prejudice. Okay, so that's very naturally modeled in the same framework. Think of the agent dividing resources between the majority and a minority individual, but they choose the extra amount to give to the minority individual, and let this parameter theta be the average relative deservingness of the minority. Let's just make it 0, so people are on average equally deserving. But then there are still differences between people. Think of this as, allocation of welfare or jobs or whatever. So on average, they are equally deserving, but there are still differences between individuals. So the agent receives a signal of the particular individual's deservingness, and this phi t is the correct posterior about this particular individual. And when based on the signal, you put a higher weight on the prior rather than the signal, that means that the signal is less accurate. Okay, so the agent receives these signals, and then allocates AT, like how much to give to one versus the other. It's a simplified distribution decision, and their perceived utility V, what they V tilde, that they think they're acting according to, is symmetric. But in reality, their actual decision utility is biased against the minority. They're not aware of this. That's how they act. And this could be this bias B could be an implicit taste. It could also be an implicit belief. It doesn't really matter. I'll interpret it as taste. Okay, so it's a very similar model. I think you can see to the previous one. What we get is that the agent's SOE belief is biased downwards. So we get the double whammy again. This is again the self-defeating nature in a different disguise or whatever. The agent has taste-based discrimination. It discriminates against the minority. And in addition to that, to explain that to himself, he now engages in inaccurate statistical discrimination too. So he develops the belief that the minority is less deserving, and that makes him even more prejudiced. So even relative to his prejudiced taste, he's too prejudiced. Sorry, even relative to his, yeah, exactly. His actions are too prejudiced. So we would make an empirical prediction that among these people who are endorsing egalitarian attitudes, the two forms of discrimination, I'm not sure how you would measure this, but we would predict that they're positively correlated. Those who hold kind of deep down taste-based prejudice, they would also believe that the other group is less deserving or worse or whatever in some form. Okay, so this implies that progression towards implicit racism from explicit to implicit may have been harmful, because now people need to explain to themselves why they are being prejudiced, and that makes them even more prejudiced. the yeah, see the double whammy. Okay, and then making them aware of their case-based, the logical reverse of this, making people aware of their case-based prejudice can be helpful, even if it's impossible to change that prejudice itself, the deep down prejudice. Even if it's impossible to change, the people knowing it would help, because at least their beliefs would be more accurate. Okay, kind of an interesting comparative static. If the signal about the minorities, or sorry, of any person is less accurate, then the negative stereotype is going to be stronger, because then people need a stronger negative stereotype to explain their behavior. So we predict not only that people act on their prejudices more in an unclear environment, but that when they frequently encounter unclear environments, they will be more prejudiced to start. That would be the prediction. Okay, so let me conclude. Just so we looked at all these problems are equidirectional problems, and at the risk of undermining everything I said, non-equidirectional problems can generate very different logic. So think of an effort allocation decision, and let's assume that the fundamental is how busy I am on average, and ST is how busy I am now. Okay, so days vary in how busy I am, but there is an average, and I want to work when I want to do a task when I'm less busy than average. So I want to choose effort based on ST minus theta. But in reality, I'm present biased, so I tend to want to do less work than usually. So this is now a question of when to do work, not about how much work to do. That's why it's not an equidirectional problem. And then what we get is we get a kind of self-confirming perception. The agent behaves as if he had no present bias, even though he has present bias and is naive about it. So, so this naivete benefits the agent in an extreme way, in the sense that he acts totally like the person who he thinks he is, even though he's not. And the intuition is that in order to explain why I'm not working, I have to believe that I'm usually very busy. But if I believe that I'm usually very busy, that counteracts my present bias, so I will work more. So we show that in some settings, this kind of perfectly offsets the present bias. Okay, I'll stop here. Okay.